Hello everyone. So in this week we're gonna continue talking about the rock properties, and we talked about porosity and permeability concepts last week, and in this week we will talk about some more properties of rock. First, we need to see if there is a relationship between porosity and permeability. So the definition of porosity was the pore volume, the amount of pore volume that you have in the rock with respect to the bulk volume, right? And permeability was an indicator of how easy fluid can transmit through the rock, right? So these two properties could be, they are not necessarily related to each other. But you can say that if you have some porosity, then there is a possibility that flow channels may exist as well, right? And you can have rocks that have very high porosity and they have zero permeabilities, and you can have rocks that have high porosity and very good permeability. So it also depends on basically absolute permeability, absolute porosity and effective porosity definition that we talked about it. And absolute porosity was basically the total pore volume, right? And the effective porosity was the sum of the interconnected pores divided by the bulk volume, right? And these two properties could be related. For example, you can see here in this picture that both of these rocks have 20% porosity. You can't see it, but it's calculated for you. But they have the same porosity, and this one have 8 millidarcy permeability, but this one have 279 millidarcy because there are more connections between all these pores, and that is what permeability is, right? So in the field, usually they try to kind of relate porosity and permeability together by plotting the data that they get from the reservoir. These data could be from the core samples that they get from the reservoir, and they test it in the laboratory. We will do these type of tests next semester. And or it could be basically the well logging. Well logging is another tools that we kind of touch on in next few slides about that. So porosity along with oil saturation, which we will talk about it again today, is basically an indication of oil in place. So how much oil you have in place. Porosity is a storage capacity, right? And oil saturation, I will talk about it, but that's basically the percentage of oil in the fluids that you have inside the reservoir, because in the reservoir you have water, you have gas, you have oil. How many percentage of that fluid overall is oil? And in combination of these two, we have the oil in place, which we do the calculations for later on. And then we have permeability indicators that basically permeability indicates that the ability to produce from the reserve, right? So if you have a low permeability, you will have very small rate of production from the reservoir because the fluid cannot really transmit easily through your porous media. You might have very high porosity though. You might have a lot of oil in the reservoir, but you're not able to take it out. And that's actually what happens in the shale resources. You have very good amount of gas or oil inside the shale reservoirs or unconventional reservoirs, but you're not able to produce, and because of very low permeability, and therefore then you need to provide permeability by doing the hydraulic fracturing. So different types of rocks have different values of porosity, from iron rich to very clean sandstones. You see how the range of permeability is changing basically. So another source that you can get the data between different rocks is to calculate the porosity and other types of basically parameters of the rock is from the logs. So well logging essentially is to send a device into the wellbore, and let's say you have a wellbore here I'm trying to use. So let's say this is your wellbore here. So you send the device through a wire line downhole, and as it goes down, it sends some signals into the reservoir or formations underground and receive them back. Now, these signals could be different type of signals, from acoustic signals, from gamma ray, all different sort of signals that we have basically in petroleum engineering. You will learn about them in a little bit next semester, and mostly in the formation evaluation course. When these devices go down, send the signal, receive it back, then you get the data. For example, sonic measures the time that an acoustic wave passes through the formations underground. Neutron measures the basically neutron emission, and it received that from the logging device. Density measures the density. So gamma ray is basically sending gamma ray, and basically I wanted to see how much gamma ray is absorbed to the formations. So gamma ray basically measures how much radioactive gamma ray it receives. So if it goes down, for example, receive very high amount of radioactive, it's basically an indication of the shale reservoirs. Usually shale have very high gamma ray. It's not written here, but it's basically more than 200 radioactive, basically API measurement. So this is basically the logging, and could basically be used as well to measure some of the properties. For example, sonic would gives us the porosity values. Sonic and neutron in combination is used to calculate the porosity of the formation. Density could give you some information about the fluids that are present, and also density can be also used for porosity again. So there are some logs that can calculate permeability as well, and if you do that, then you can have a full map of porosity, full map of permeability, and basically compare them together and see if they match, plot them together in a cross plots. So I guess that's it. We talked about the porosity, permeability, the concept of them, how they might be related to each other. We'll talk about these concepts later on in rock fluid properties in much more details. So that's it for this video, and I'm gonna continue in the next video.